While programming, you often need to convert one value into another by applying multiple operations one after the other. Let's visualize this as a pipeline where we apply successive function calls with the return value of each being the input of the next. Take this JavaScript example where we want to make a database query about a user, then get the gender of their best friend. In this case, any one of these functions could fail, such as if the database is down or if the user has no friends, or even if their best friend doesn't have a gender. Assuming that a failure results in null value, it could be problematic passing a null into a function that expects something else. To remedy, you would probably add a bunch of checks after each function call, but this is verbose and quite frankly, ugly. It also makes this code very hard to read since you focus more on the implementation details than the actual operation. To refactor, let's create a class called maybe. Its constructor will simply take a value and store it inside the object instance. We'll also give this class a method called bind, which takes a function as a parameter. This method would simply apply the function to its inner value and return a new instance of maybe with the new value. Once we have this, we can rewrite our original pipeline by using a set of chained bind calls on a maybe instance. You would notice that now there is only one place where functions are being called, which is within the bind method. This means you can add any extra logic or computation there, and it will apply at every step of the pipeline. For this example, let's add a check to return itself if the object contains a null. Not only is this a lot more readable, but any changes can be made to just one place. What we have is a design pattern in which we abstract pipeline implementation details by wrapping a value in a type. When you hear monad in the context of computer science, just think of it as being that. So you might be wondering then, why are these such a big deal in Haskell? Firstly, this code here describes what we want and not how to do it, which makes it declarative as opposed to the original imperative version. As a functional language, Haskell goddamn loves its declarative code. As such, it encourages the use of monads by providing built-ins such as the maybe monad we created earlier, meaning you can use them without putting in the work of actually making them. It also has a special bind operator which removes most of the clutter our .bind calls added. In other languages, you can generally reassign variables and modify state, but Haskell does not let you do this. Thankfully, since monads are object instances, they can store some extra data. Let's modify our JavaScript example to keep a log of every step of the pipeline. The properties of this monad object effectively simulate a sort of mutable state, but still only using immutable data. I'm gonna end this video here. If anything wasn't clear, please leave a comment and I'll try my best to clarify.